Oh, good afternoon, everyone. I want to welcome you to another beautiful week. And of course, today we're going to continue from probabilistic or graphical model. I will start on Friday. And of course, I told you on Friday, we got ways to represent probabilistic relationship among variables. Of course, I also told you we got two types of probabilistic graphical model. So and we're only focusing on the Bayesian network aspect, because the Bayesian network aspect is what we call the directed graph. We got the directed graph, we got undirected graph. So the Bayesian network is actually the same as the directed graph. So what we want to do today, since I've already introduced you to introduction, I want to walk you through some work examples on, Bayesian network. And of course, I told you the other time, because we're able to, with Bayesian network, we're able to capture probabilistic relationship among variables, and that gives us opportunity, an avenue to be able to represent uncertainty, because, in a probabilistic space, there's always room for randomness. And how do we quantify? If we really want to understand our environment, of course, we need to be able to know how we can quantify randomness, okay, how we can represent uncertainty, okay, and of course, Bayesian network, because it enables us to view the relationship among variables in a probabilistic version using the graph. That gives us opportunity, if we really want to make our inference. Okay, making inference is making judgment, just like what I said. And of course, this is applicable in image processing, in medicine, in economics, in forecasting, and so on like that. Of course, I remember on Friday I mentioned speech recognition, despite the fact that there's variation in pronunciations. Of course, using the relationship between acoustic signal and phonemes, of course, we're able to have an accurate transcription. Okay, so actually want to move right now. Okay, so like I said in the outline, um, we're focusing on Bayesian network and of course our application. What I need from you is, I need you to be focused. I want to introduce you to a practical example. Please be focused. It's a practical example. Okay, now you remember when I was walking you through this on Friday, I show you a structure, we got nodes. Okay, this guy here, give me 1 second. Okay, this guy, okay, this guy, that is actually what we call nodes. Okay, that's what we call nodes. Nodes. Okay, nodes represent random variables. Okay, node represent random variables. Okay, node represent random variables. Okay, of course, the next chapter in this course is going to be random variable. So, of course, by random variable, we're trying to say sprinkler, the use of sprinkler varies depending on the weather condition. We may use it or not. Okay, then they said that we got a rain or not. Then they said that the grass is wet or not. So that kind of random variable is discrete. Okay, discrete. Okay, we're still going to talk about all of that. There are two types of random variable. We got discrete, we got continuous. The discrete one are those ones that have levels that I just talk about right now. Now, What about what about the edge? This guy actually represent the edge. Hedge. Okay? That represent hedge. And what is the function of hedge? The hedge actually indicate probabilistic dependencies or probabilistic relationship. Okay? Probabilistic dependencies or probabilistic relationship. That's what it means. Okay? If you don't understand, please ask me question because um if you understand the components of the graphical structure, of course you'll be able to pass excellently whenever I set a question on probabilistic graphical model. Okay, now we got three nodes here indicating we got three variables. Okay, three random variables. Okay, now I need you to take a look at it. Rain. Okay, no, and rain does not have a parent according to this structure. Sprinkler has a parent. Okay, the parent of sprinkler is rain. And grass wet has two parents. What are the two parents? Sprinkler and rain. Now let me tell you the situation. I wake up one day in my room, maybe I now open my door, right? And I discover the grass wet. Okay, I discover my grass wet. Now, if my grass wet, and I want to be able to retrace what could be responsible for that, it's either the sprinkler is on, and the sprinkler can only be on probably during the summer, right? Okay, or incidents of rain. Okay, now if I'm now interested in getting the probabilistic occurrence, like if I want to figure out the probability of the joint occurrence of these three events, where S, the sprinkler now is X, this is R, and this is G. Okay, when you take a look at that guy, what I actually want to do is to figure out the probability of the joint occurrence of the three events. Because let me tell you this, there's possibility. The three events can happen at the same time. Okay, rain may be falling, and you could incidentally operate your sprinkler may be on and the grass is wet. You want to figure out the three events at the same time. So if you want to figure out the three events at the same time, of course you're going to make use of the structure. Okay, are you surprised? Are you surprised with this? That is the rain starting alone, right? Then the probability of sprinkler. Okay, if you take a look at that now, sprinkler depending on rain, okay, which is the relationship here. Sprinkler depending on rain, okay, and the grass wet. Take a look at this guy. The grass wet depending on the two. Is there anyone in this class who doesn't understand how we figure this guy out using the graphical structure? Is there anyone? You okay, right? Okay. Now, that is the probability of the joint occurrence. Now, this is the general form because X that you see, okay, X in X here, okay, it represent X, R, and G. Okay, that's a random variable. That's a multivariate. Okay, so the P of Xi, the parent of Xi, like Xi, X1 is like X. It's a sprinkler, X2 is a rain, and X3. So in this situation now, our n is equal to 3, that which is the numbers of variables, right? Okay, now we want to move right now. Now, how do we make inference? I told you the other time, using that graphical structure, we find the probability of the joint occurrence, right? We could be looking for different kind of probabilistic queries. What if in a situation where the interest is, I just want to get the probability that my grass is wet. If I want to get a probability that my grass is wet, I'm actually going to make use of the joint that we got the other time from the graphical structure. So what I'm going to do now, it means if I want to get a probability of my grass is wet, that indicates I'm not interested in rain, I'm not interested in sprinkler, then I'm going to sum them out. So what am I doing here? What I'm trying to do here is I'm actually summing the total. This is like a total. I'm actually summing this total over the range of the variables I'm not interested in. Because right now, I'm only interested in probability of grass is wet. And if you take a look at that guy, don't forget, from the structure, that probability of SRG is that guy based on the graphical structure. Okay? So this is one of the probabilistic queries that we may want to answer. Let me tell you this. Why do we need probabilistic graphical model? Because we want to answer probability question. Okay, we want to answer probability question, okay, using the graphical structure. Okay, now, some of you may be wondering, how do we have the graphical structure? We use the domain knowledge, or you say expert knowledge, to be able to draw the graph. The expert that understand the relationship. Okay, if you want to do this in economics, maybe you want to draw graphical structure for economic variables, then you need the expert knowledge of those who understand economic relationship. Does that make sense? Wherever you want to apply this, you need an expert knowledge. But let me tell you this, even without expert knowledge, we can learn the structure from the data. We got a software to do that. Does that make sense? Okay. But when we work with expert knowledge, and if expert knowledge is correct, don't forget, there could be some expert knowledge that could be misleading. Okay. We got to be very, very careful. Okay. Now, I may also want to take a look at this guy. What do I want to find? I want to find the probability that my grass is wet given rain. Take a look at that. Now, my grass is wet or given rain. Okay. Now, I'm actually going to be needing this guy. I need the because I say given rain, you also need the total for the instead apart from the gas well, don't forget you also have sprinkler, right? Which means what you want to do, you want to marginalize. You actually want to sum over the sprinkler, because here we don't talk about sprinkler. We're not interested in sprinkler. Okay. Now, if you take a look at what I have now, take a look at it. XG given R. Okay. Now, which is going to be, I can split this guy into this, which is going to be S given R. Don't forget, sprinkler depends also on rain. Okay. Now, then G given all of that. So that is another way to put that guy. Okay. Now, I want to go into something else. Oh my God, this has a lot of application. Let me just first come to student performance. Okay, take a look at this. I need you to pay attention. We have difficulty. I'm talking about class. A class may be difficult or easy, like this class now. Okay, difficult or easy. Intelligence, students may be smart or not. Two variables. Grade. Okay, now let's say I actually have three classifications for grade: excellent, okay, good, and average. Okay, now this has three levels. SAT score. A SAT score could be low or high, right? Letter. Maybe when you graduate and you want to go to, some students have approached me to write letter of recommendation. Now, it's either the letter of recommendation that I'm actually going to write is either going to be weak or strong. Does that make sense? So what am I? Let's say I refer to myself as an absent-minded professor that doesn't remember my student names. Okay, and the student has approached me for letter of recommendation. I'm gonna use the grade. If I normally somebody I don't remember them, I'm just okay. You know what? Can you send me your transcript? But it's not all I had. A good number of students I've graduated through me. Now, I don't forget, grade depend on whether the class is difficult or not. Then also depend on the intelligence of the student, and of course, SAT also depend. Now, take a look at this graphical structure. Now, each of, how many variables do we got? We got 5 variables, right? Okay, let me tell you this. This 2, 2, 3, 2, 2. Okay, if we don't want to use, do you know the meaning of what I just assigned? Okay, difficulty, it could be difficult or easy. A class could be difficult or easy. I'm talking about levels right now. Talking about levels. Okay, these are random variable, and don't forget I told you they are discrete in nature. Okay, and they got levels. Okay, intelligence 2. Okay, smart or not. Grade 3. Okay, excellent, good, average. SAT score could be low or high. Letter of recommendation could be weak or strong. If I don't want to use graphical structure, if I want to assume absolute independence, do you know the numbers of parameters we're going to have? The numbers of parameters we're going to have will be huge. Multiply all of that. 2 times 2 times 2, that would be 2 times 2, 4, 4 times 2, 8, 8 times 3, 16, 16 times, like 32 numbers of that. That's a lot. That's a lot. Okay. Now, but with probabilistic graphical model, the numbers of parameters we're going to have, okay, will be less. Because when you got so many parameters in your parameter space, okay, it creates what I call estimation problem, okay, computation problem. Well, now take a look at it. Let me just assign values now. Now, I need you to pay attention now. Something is calling me. Oh my God, what is this? Because each of these variable are random variable, okay, then we'll be able to get what is the frequency, what is the likelihood of a particular random variable given the parent node. Let's take a look at this guy. What are we trying to say? Now, I need you to pay, there's an information that I'm going to give you about. Okay, so take note of this guy. When you see DO, D1, what is it meaning? Okay, now this is, give me 1 second. This is easy, hard. Does that make sense to you now? Which means 60% of a time, that class is easy. The class, which class of students requesting for letter of accommodation. Okay, so then high 0, so non-smart, then smart. Please take notes. Okay, so what about SAT? Or what about XO and the X1? Low score, this low score, okay, high score, okay. Now what about grade? Okay, this guy excellent, okay, good, average, okay. It's not I say we don't have poor, but I want to believe somebody who have a very poor result, may not request for letter of recommendation. Okay, so take a look at that. We're just assuming that anything is happen, anything can happen right now. Okay, now letter, okay, weak, strong. Any question? Now let me tell you, how do we assign figures? That is based on experience. Okay, 70% of the time, 70% of students not smart, 30%. Okay, but let me tell you, as far as I'm concerned in this class, 100% smart. Okay, now I need you to pay attention to something now. We got 2 levels here. Okay, we got 2 levels here. Now, when I want to talk about grade, now, in grade, we got 3 levels in grade. Okay, now if you don't forget grade, if I want to write something here, I'm going to write the grade based on difficulty and based on intelligence. Okay, now take a look at this. How many cells do I have here? Okay, 12. Why do I have 12? 3 levels here times 2 times 2. Does that make sense? You got 3 levels, 2, 2. If you multiply them, that's going to be 8. That is why that's going to be 12. 3 times 2 times 2, 12. That's why you have 1, 2, 3. That's why you got 12 cells. Does that make sense? Now, what is this guy telling you? Okay, 90%. Okay, so what we're trying to say, okay, what is I1? Okay, okay, intelligent students. What is D0? Okay, easy, which means an intelligent student in an easy class. Okay, 90% of the time is going to score an excellent score. Let's reason. An intelligent student in an easy class, okay, class that is easy, 90% of time, 90% of time, okay, is going to have an excellent grade. Then what about this one? Okay, so that same 8% of time is going to have a good grade, like good. And we're talking about an intelligent, we're talking about I1, talking about smart students, okay, in an easy class. Okay, then take a look at it. Then they could have average too, but only small. Look at that, 2%. Okay, so there's a lot of reason why students may fail an exam. It could be a lot of maybe that kind of student may be facing crises, mental issue, and so on like that. Now, do you understand all these ones? Okay, and you know the reason why we have 12 cells, right? Okay, now take a look at this guy. Okay, why do we have 4? Because SAT has 2 levels, intelligence has 2 levels, 2 times 2, that's going to be 4. Okay, and of course, if you take a look at this, we don't know it right now. It may even be the one that we want to calculate, and at times we could know that. Let me put that. Now, what is the meaning? Why do we have 6? Okay. We got 6 because letter depends on grade. Got 2 levels of 2 levels here. How many level? 3. 2 times 3, that will be 6. That's why you have this. Now, how can you interpret this? Let's see. Okay, 99%. What is happening here? What is G3? Average, only focus grade. Okay, so let me reinterpret this. 99% of the time, okay, student with weak, student with the average result, because the letter is only based on grade. Even though we know that this letter has a grandparent, we are not considering what is a grandparent? Intelligent, because intelligent determine this. In fact, this has 2 grandparents, difficulty and intelligence, but we're not interested in grandparent. We are interested in a direct descendant. Okay, so what I'm trying to say here is 99% of the time, the professor will write weak recommendation to students who have average grade. Does that make sense? That's what it means. Okay, now, any question on that? Because you need to be able to understand, how to interpret all of that. Now, we want to come to medical diagnosis. An expert gave us this. What if I give you this in an exam? Write the probability of the joint occurrence of all the variables. You look at the structure, and I can also say, what is the probability of getting COVID-19? Oh, the probability of getting COVID-19. After writing the joint, then you're going to write, you're going to do what? You're going to sum out all the variables. There's going to be a lot of summations. Any question on this? Go ahead. That's a very good question. How do we sum out a variables? And that is, I'm still going to show you, that's going to be part of what we're going to do. But you know what? Situation where we got a lot of variables, we use software. But that is going to be go beyond the scope of this course. Okay, but I'm just going to walk you with the one with few variables. Okay, that's a good question. Okay, now you understand this. So we can be able to determine the probability. Don't forget, probabilistic relationship exists among COVID-19 and other variables, influenza B, coronavirus, HKU, and so on like that. Look at that. Is that not interesting? Very, very interesting. And this actually work better than conventional approach. Okay, so in medical diagnosis, it actually work. Take a look at that. Okay. Of course, when somebody have a COVID, it's either the person go to regular ward or that ward. And it is not only COVID patient that comes here. Okay, take a look at that. Even you see that there's a lot of connections, probabilistic connections. Okay, now we want to move right now to something else. Oh my God, what about lung cancer? Diagnosis of whatever disease. Like now we're talking about lung cancer. Okay, we're talking about lung cancer, and of course, they're looking at the parents. What is the main parents in the lung cancer? Smokes. Okay, smokes, lung disease, shortness of breath. These are symptoms. Okay, cold, cough, fever. Now you understand all of that represent right now, right? You can find the probability of the joint occurrence of all the variables, and at the same time, you can also figure out the probability of a certain variable of interest. Is that not interesting? Oh, supply chain, supply chain. Take a look at that, the supply chain. I remember, this very picture was actually of, I think they used what happened in Japan. That was, I think, was it in 2011? I think that was an earthquake, right? Okay, now take a look at this. How many suppliers? Three major suppliers. Supplier one, supplier two. Okay, now we got global disruption and local local disruption. Now, if you take a look at supplier one, okay, what affects supplier one? Labor strike, flood, okay, and fire. And not only that, you know, supplier one, take a look at that, also affects economic collapse globally, because Japan economy also has impact in the world. Okay, now this is a graphical structure where the knowledge of probabilistic graphical model can actually be used. Take a look at that. Okay, now I want to move. Oh my God, I'm coming into criminal justice system. In the criminal justice system, okay, there is something that we call when that is used in the court of law when when an accused is already proven guilty. Okay, they normally consider the recidivate. Recidivate means what is the probability that he or she will commit the offense again, because those are the kind of I think they call it aggravating factors that jury look into before sentencing. These two individuals, they may have the same offense, but by the time they consider some aggravating factors, they could have different sentences. Does that make sense? It's not as if that the court is not fair, okay? But they have to. Now, what we're trying to say here, that the probability that an offender is going to reoffend depends on prior conviction or prior, and also depend on type of crime. Does that make sense? So that depends on type of crime, and prior conviction depends on whether it is a juvenile felony or juvenile, misdemeanor. So take a look at that. Okay, expert knowledge in judicial system help us with this relationship, and we believe these are random variable, okay, and probabilistic relationship exists among them. Let me tell you this, because of the fact that we live in stochastic environment, of course we need to be reasoning. We need to have a probabilistic reasoning of the world. If you want to understand the world, you have to live the world probabilistically. Okay, that's all we mean. Okay, so take a look at it. In the criminal justice system, of course, and at the end of the day, they will find out if they find with this net from this network, they will be able to find that probability that that person will actually reoffend. Okay, and that will play a long role in sentencing. And that is the reason why, at times different offenders get different sentences. Okay, now based on that structure, then this is the probability of, let's take a look at this now. When I multiply all of this is based on the structure here, the one for the criminal justice system. Okay, it's based on this structure. Of course, you can write that. Is there anyone who cannot write the probability of the joint? Okay, if you want to start, it's going to be probability of this times probability of that, right? Okay, it's going to be, you're going to start with probability of that times probability of that. So those ones, they do not have parents. We actually call them marginal probability, or we call them unconditional probability because they don't have parent. But this guy here, of course, they have parent. If I want to write this guy now, it's going to be probability of priors giving this and that. If I want to write the type of crime, the probability of the type of crime given those two. If I want to write the probability of the recidivate, so it's going to be probability of this given priors and type of crime. Any question? That's super easy, right? Now, look at what we've done today. And this was used in county in Florida. Okay, the way they generate compass. You can search compass. Okay, that's a compass score. They generate compass score. I think they also call it Desai score. Desai score. Actually, it's ranging from 0 to 10. Oh my God. The moment they compute something from 6 and above, that offender has high probability of reoffending, and that offender could get a longer sentence. Okay, now I want to move right now. Let's move. Oh my God, let's move. Okay. Oh my God, look at another application, weather forecasting. Take a look at this. You know what is the probability of rain tomorrow? Oh, the probability of rain tomorrow depend on humidity at 3 p.m. Humidity at 3 p.m. depend on humidity at 9 a.m. And the rain tomorrow depend on the wind speed. Now take a look at humidity at 9 a.m. Okay, 30 point something percent of the time, okay, it is less or equal to 60, and 69 point something percent of the time is greater than 60. You can see the random variable, and of course the probability of rain tomorrow. This guy is actually going to base on humidity at 3 p.m. and that guy, and of course we are expecting how many cells. Okay, I think there should be a lot of cells, because if this is depending on this and this, we got 3 times 4. This guy should be 12. Let's see. That should be 12. Oh my God. You see that it's actually 12. Okay. Give me 1 second. Okay, so you can see it's actually, we got 12 cells, right? And of course, don't forget, rain tomorrow depends on humidity at 3 p.m. and of course, wind speed. And that's why you can see different. So this who help us here is, we call them maybe meteorologists, those who actually handle weather forecasts. Okay, with this information here, we'll be able to answer some probability queries. Okay, now there was, I don't know whether some of you that how many of you are in law or have a major or non-major in law or minor in law? Okay, now there was a case, that was a celebrated case in the United States. I think that was in 1996, but involving Simpson. There was a man called Simpson. He was accused of murder, and at the end of the day, he was discharged and acquitted despite overwhelming evidence. Okay, you know, actually, the prosecutor of, I mean, sorry, the accused, Anthony, actually changed the trajectory of the case to something else, to situation. He actually ignored the fact that somebody was murdered to, the aggressive behavior of LAPD, Los Angeles Police Department, to particular race. Okay, and at the end of the day, so the idea of probabilistic graphical model. Okay, Simpson wife was murdered, and they actually discover there's a lot of evidence. I'm going to tell you now. Number one, Simpson used to abuse his wife. That's one of the factor. Then Simpson killed Brown. Okay, it's an assumption. This is like, what is the probability that Simpson will kill Brown given that he abused? So they're going to look on record. Okay, what is the probability that if somebody abuse his wife is going to end up killing them? Okay, the data is available. Then Simpson, when somebody abuse somebody's wife, of course, can also be the person. Okay, then uh, you know, it is not only Simpson's wife that was killed. Okay, Godman, you know, before uh Brown was murdered, okay, they had a divorce, and you know, Godman was now having relationship with Brown. Okay, so a lot of people believe that Simpson killed them because Simpson was jealous. Okay, so take a look at that. Now they found a blood, sock, okay, in his compound. Okay, and what about the blood stains in Bronco? He had a car. They saw, a blood stain. Then a gloves. They also saw, the blood stain. Then the blood at the crime scene. Then another thing is, there is a person that also lied in the process among the prosecutor. They believe that that person is among those who frame Simpson, because at that time the Los Angeles department they had aggressive behavior. It was alleged that they have aggressive behavior, towards a particular race, and of course Simpson belonged to that race. Okay, then, but there was a video on YouTube. One of the reasons why Simpson was actually discharged and acquitted. Okay, the hand glove found on the scene, they asked Simpson to wear it in the court of law, and that hand glove didn't fit. That was one of the reasons why they have to discharge him and acquitted, and they believe that it was LAPD, Los Angeles Police Department, that framed all those evidences. Okay, and they also found that the Brown and Goma, they also have drug-related issue, that it could be maybe they were killed due to, you know. So I'm just trying to say, in litigation, even though I don't pray to go to court, even if that's why I try to avoid, confrontation, because the lawyer could be gullible. Okay, the lawyer could be manipulated, and we live the environment we live. Anything can happen. Okay, now I want to go into calculation now. I've already shown you. Like, we're doing this today. We're going to finish it tomorrow, on Wednesday. Okay, but I'm going to start. But this is where I need you right now. Calculations. I told you the giant structure I showed you the other time can be implemented using statistical software, Python, R, Tableau, and so on like that. But you know what? The one we're going to be dealing with in the class, we actually going to be computing, and we're not going to have so many variables. Okay, I need you to pay attention to this guy now. Let's take a look at this. We got 4 variables, C, A, B, C, D, but I want you to look at the structure. Okay, looking at the structure, D depends on B, right? Do you see the arrow? And B depends on A. Yeah. Then A, if you take a look at C, depend on A. Okay, I need you to take a look at the arrow. They give you this information. Okay. If I want to know, the probability of C will be conditioned on A. A is a parent. And don't forget, it's either A is true. When A is true, it's just A. When A is false, that is A complement. Does that make sense? Now, so right here, if I know the probability of A, I know the probability of A complement. It's just going to be 1 minus that. Now here, you've now been given, take a look at what you have here, okay? The probability of C given A is 0.8. The probability of C given A complement is 0.3. Any question? Okay, now take a look at this guy. It has to be probability of B given A because B depend on A. Look at the direction of the arrow. So the probability of B given A is 0.8. The probability of B given A complement is 0.3. Any question? Okay. Let me tell you this. This and this, we don't expect them to be one. They are totally different. Okay. Okay. Now take a look at this guy. The D depend on B, right? The probability of D given B is 0.8. Probability of D given B complement is 0.3. Any question? Now you are given all this. Now, if you are given all this, I want us to calculate something. Okay, given that now, want to calculate something now. Number one, okay, what is the probability of A? What is the probability of D given A? Please pay attention. What if I ask you this in exam? What is the probability of D, okay, given A? Now, you will follow from the conditional probability I gave you the other time. The is going to be probability of DA divided by probability of A. You remember? The probability of D given A is going to be equal to the probability of the joint divided by probability of A. Now, I need you to pay attention now. Oh my God, the probability of DA is going to serve as a total probability. You know why? Let's say DA. DA. There is something in between them. What is that? B. Now we're going to view that as a total probability. It's either that A is observed or it is not. So I'm going to say the probability of D given A, the numerator now, I'm actually going to say the probability of D, A, B, plus the probability of D, A, B, complement divided by probability of A. Any question? Because the probability of DA becomes a total probability if there's a variable in between them. Now, it's either, now where I wrote B, okay, together with these two means it may be observed or it may not be observed. You see the B complement, right? If you don't understand, ask me a question. If you don't understand, ask me a question. Or maybe you guys are not saying that. Let me just let me use space. Okay, this is what I'm saying. Here I said the probability of D given A from conditional probability is D A or D intercept A, it doesn't matter. Okay, now when I take a look at D and A, there is a B in between them. It's either the B is observed or not. So what I'm going to do now, so I'm going to write the probability of D given A is going to be the probability of D A, B, then plus the probability of D A B complement divided by probability of A. Any question? Okay, now what I want to do now is actually, if I want to write the probability of DAB, I need to write the probability of DAB. I also need to write the probability of DAB complement. Okay, now if I want to write also the probability, okay, of D, okay, A, B, is going to be the probability of D given AB multiplied by probability of AB. Now, I need to pay attention. The probability of DAB. Oh, do you remember the law? Multiplication rule for dependent. Do you remember? If I want to write the probability of D, A, B, okay, and don't forget, if I want to write it in a conditional way, based on the structure, what happened? D depends on both B and A. That was why you see this guy. Then that would be multiplied by the prior. What is a prior now? Before, which don't forget, D depends on A and B, then A and B becomes the prior. And that was why you see multiplied by probability of AB. Now I'm going to do the same to D, A, B complement, which is, I'm just going to write the same thing, except that I'm actually going to be changing wherever I say B is going to have a complement. Take a look at that. Is that not beautiful? Look at that. That's beautiful, right? I'm not going to rush you. I'm going to continue on Wednesday. Does that make sense? I don't want to rush you. Okay? We're not done. We're gonna continue from here, because what do we need to do next? What we need to do next now, what is it? What is this? And what is this? But let me tell you this. Do you know that this guy, when D depends, when D depends on B and depends on A, then we need the direct descendants. We don't need the grandparents. This guy is going to be the same as probability of D given. What is the direct descendant? What, according to the structure, what is the direct descendant of D? B. So this is going to be, so this guy here will be written as probability of D given B complement plus the probability of A, comma B complement, and the same thing here, the probability of D given B multiplied by probability of A, comma B. Look at that. That's what I'm going to have. Like I said, I'm going to continue from here next on Wednesday. Go ahead. You mean say multiply? Which one? Oh, in the bottom. Oh, sorry. You mean this one? It should be multiply, because this is for this guy, and I'm still repeating this guy here. Okay, any question before we go? This is where we're gonna stop. We're gonna continue from here. But you know what? Take your time. Take your time. Take your time, because we're gonna be dealing with calculations now, and these are very crucial for midterm one. Okay. Make sure you all stay safe and have a lovely day. Gonna see you on Wednesday. Okay? We'll continue with that on Wednesday. You're welcome. And you too.